Okay, so this is the problem we stopped on in class, and this is a situation where we're going to have dependent equations, and we just need to see how that plays out when we have a matrix and how we can write the solutions to the equation, just showing the relationship between x and y, since there will be an infinite number of solutions for this problem, because really these are the same line. These two equations are equivalent. But I'll try to keep that a secret for a minute. It's really hard to do because if you just multiply the first equation by 4, it looks exactly like the second equation, but we won't do that. We'll say, how about if we multiply the first equation by 100 to get rid of those decimals? So that would be 25x minus 75y equals 100. And then the second equation, if we move the 3y to the right and the 4 to the left, we will have x minus 3y equals 4. And if we put this into a matrix, we're going to have 25, negative 75, 100, and 1, negative 3, 4. All right, so if we were going to solve this, we would want to switch the two equations. So we would switch our 1 with our 2 because our 2 has a 1, a leading 1, and we want that in the first row. So 1, negative 3, 4 in the first row, and 25, negative 75, 100 in the second row. And so if we wanted to get rid of that 25, which we would want to, we would do that by multiplying the first row by negative 25, so negative 25 R1, and then add that to the second row and replace the second row with whatever we get. Negative 25 times R1 is going to be negative 25, 75, and negative 100, and then R2 is 25, negative 75, 100, and so you can see if we do this, we're going to get all zeros. So the matrix will have all zeros in that last row, and it will have this still in the first row. And so what that tells us is 0 plus 0 equals 0, which is true, but it doesn't really give us a lot of information about what x or y is, because the reason is because, as I said, these two equations represent the same exact line. It means that there are an infinite number of solutions. And so what you want to do is just give a solution that shows the relationship between x and y. So the equation we have, 1, negative 3, 4, that top row, just tells us that x minus 3y equals 4. So the relationship is that x is equal to 3y plus 4. Then we can represent the solution to this system of equations with the point 3y plus 4, that's your x, and y is your y. So you're just showing the relationship between x and y. So this is x, this is y. If you solve this equation for y instead of x, the other way you could write the solution to the system of equations would be to say x, and then 1/3 x minus 4/3 for y. Okay, so now we have a system of 3 equations and 3 unknowns, and we'll see what happens with this. It's already in order, so we'll go ahead and write it as a matrix. So we've got 1, negative 4, 7, 14, negative 2, 9, negative 16, negative 31, and 1, negative 7, 13, 23. So we already have a leading 1 in our first row, so we don't need to change anything about that. But we can get a 0 and a 0 in the second 2 rows on the first column just by multiplying the first row by something and then adding that to the row we want to change. So for the second row, what we will do is we will multiply the first row by 2, so 2R1. We'll add that to the second row, and then we'll replace the second row with what we get. And then for the third row, we will multiply the first row by negative 1, so negative R1. We'll add that to the third row, and that's what we'll put for our third row. So we'll do that down here. So 2 times R1 is going to be 2, negative 8, 14, 28. And then our 2 is just -2, 9, -16, -31. And if we add that up, we have 0, 1, -2, -3. So that'll be our new second row. So I'll just write the first row because it's not going to change. So second row will be 0, 1, -2, -3. And then for the third row, we are taking the opposite of first row. So -1, 4, -7, -14. And we're going to add that to the third row, which is 1, -7, 13, 23. So this was -R1, and this is R3. And we're adding them up. We'll get 0, -3, 6, 9. All right, so that's our new third row, 0, -3, 6, 9. All right, so we have our first column just the way we want it. The second row has a 1 in its as its leading term, and that 1 is to the right of the 1 in the first row, so that's all good. Now we just need to get rid of that -3 that's underneath that 1 in the second row. So to do that, we will multiply the second row by +3 and add it to the third row. So I'm going to erase this. So we want to get rid of that -3 that is under the 1 so that we'll have all zeros under that middle 1. So to do that, we are going to multiply the second row by 3. So 3R2, and we're going to add that to the third row, and then we're going to make that our new third row. All right, so our first row won't change. It will continue to be what it is. And our second row won't change. And so if we do this, we've got 3R2, which is going to be 0, 3, -6, -9. And if we add that to R3, which is 0, -3, 6, 9, we can see that we're going to get all zeros for the third row. All right, so that tells me these three equations are dependent. But before we can really understand the relationship between the three equations, we need to finish getting it into reduced row echelon form. So to do that, first of all, we need to get a 0 here next to the 1 in the first row. And to do that, we will multiply the second equation by 4. So 4R2. We're going to add that to R1, and that's going to be our new row 1. So we will leave our bottom row the way it is. We will leave our second row the way it is. And I keep forgetting to put the line. There we go. And so when we do this, this will be our new first row. All right, so let's go ahead and do it. We've got 4R2. So that is 0, 4, -8, -12. And we're going to add that to R1, which is 1, -4, 7, 14. So we're going to have 1, 0, -1, 2. And that's going to be our new first row. So 1, 0, -1, 2. And so since these equations that are represented here are x minus z equals 2 for the first row and y minus 2z equals -3 for the second row, both of the equations have z. So we could write our solution in terms of z because we can write x in terms of z and y in terms of z. So if we just put z for itself, then because of the first equation, we know that x is equal to z plus 2. We can put that for x. And we know that y, if we solve for y here, y is equal to 2z minus 3. So that would be our y. So this is the kind of solution you want to put when you have dependent equations as this, z plus 2 for the x-coordinate, 2z minus 3 for the y-coordinate, and z for for the z coordinate, and you would say that z is just any real number. Okay, we have another system here. If we go ahead and get this into row echelon form, even though there's no third equation, at least we'll know how the coordinates are related to each other. So we've got 3, -8, 18, 15, and we've got 1, -3, 4, 6. Now we will want to switch the equations around. So 1, -3, 4, 6, and then 3, -8, 18, 15. And now we want to multiply the first equation by -3 and add it to the second equation so that we can get a 0 in the first spot in the second equation. We'd say -3 times row 1 plus row 2, and we're going to replace row 2 with what we get. So if we do that, -3 times row 1 is going to be -3, +9, -12, -18, and row 2 is 3, -8, 18, 15. We add that up, we've got 0, 1, 6, and -3. So that's our new row 2. So first row is still 1, -3, 4, 6. Forgot to put the line. And the second row is now 0, 1, 6, -3. And now we would want to make this a 0. So we'll multiply the second equation by 3 and add it to the first equation. So 3 times row 2 plus row 1. And we're going to replace row 1 with that, whatever we get. So 3 times row 2 is equal to 0, 3, 18, -9, and our 1 is 1, -3, 4, 6. Add it all up, you get 1, 0, 22, -3. So that's going to be our new row 1. 1, 0, 22, -3. And row 2 stays the way it is. So that's really about as far as we can go with that one. So if we go ahead and write the equations that we end up with, we've got x plus 22z equals -3, and we have y plus 6z equals -3. And so if we want to write the solution set, we can solve for x and y just like we did last time. So the first equation would be x equals -22z minus 3, and y equals -6z minus 3. And so that's what our solution set is going to look like. It'll be -22z minus 3 for the x-coordinate, -6z minus 3 for the y-coordinate, and z for the z-coordinate, and that's for all real numbers, z. We got another one. Let's see what happens. So you can pretty well see that if you, like, for example, let's say you decided to multiply the first equation by -1 and add it to the second equation and replace the second equation with that, and you multiply the first equation by -2 and add it to the third equation and replace the third equation with that, then what's going to happen is you're going to have the first equation doesn't change. Forgot the line again. And so when you multiply the first equation by -1 and add it to the second equation, you end up with 0, 0, 0, 0. And when you multiply the first equation by -2 and add it to the third equation, you get 0, 0, 0, 0. So nothing really was accomplished here. You just still have the first equation, x plus 2y plus 3z equals 6. And all this is telling you is that these are all the same plane. And so there's a couple ways you can write the solution. You could write x in terms of y and z. So you could write -2y minus 3z plus 6 for your x-coordinate, and then y and z are all y and z in the reals. Another way you could write it would just be to write x, y, z such that x plus 2y plus 3z equals 6. But you could also write this with y being in terms of x and z, or z being in terms of x and y. Okay, so this is an application about dependent systems. So consider the network of 4 one-way streets shown in the figure. In the figure, x sub 1, x sub 2, x sub 3, and x sub 4 indicate flow rates in vehicles per hour along the stretches of roads AB, BC, CD, and DA, respectively. The other numbers in the figure indicate other flow rates moving into and out of intersections A, B, C, and D. So we're going to, first of all, set up a system of equations that represents the traffic flowing freely. So the flow rate into an intersection has to equal the flow rate out of the intersection in order for traffic to flow freely. We have 4 intersections, A, B, C, and D. There's traffic flowing into each one and traffic flowing out of each one, and we're going to set those equal. So if you look at intersection A, you've got traffic coming in right there from the left side, and you've got traffic coming in from south, I guess, if that's south, it's coming in from the south. So those are the only 2 ways to get into intersection A. So that's the flow rate going in is the 216 vehicles per hour on the left, and x sub 4. The traffic that flows out of that intersection will either go straight up or it will go to the right. And that's 356 plus x sub 1. So those 2 things need to be equal in order for traffic to flow freely. Intersection B, you've got traffic coming in from the left and from the top, and traffic going out. Well, that's the traffic going in, so that's x sub 1 plus 298. And then you've got traffic going out. It either goes out to the right or it can go out down. And then for intersection C, you've got traffic coming in, x sub 2, or the 247 coming from the right. So that's the traffic going in. And then the traffic going out is going either down or to the left, and that's 281 plus x sub 3. And then for intersection D, you've got traffic coming in from below, 315, or coming from the right, x sub 3. And then you've got traffic flowing out either to the left, 273, or straight up, x sub 4. So those are all the things that equal each other. And so that's 4 equations. So I'm just going to rearrange each equation so that you have x sub 1, x sub 2, x sub 3, x sub 4. Those values I'll put on the left side of each equation, and then I'll put the constant on the right side. So for the first equation, if we move everything around, we're going to have x sub 1 minus x sub 4 equals negative 140. And for equation B, you're going to have x sub 1 minus x sub 2 equals negative 132. And equation C, you'll have x sub 2 minus x sub 3, and then you subtract 247 on both sides, and you'll have 34 on the right. And then for equation D, you've got x sub 3 minus x sub 4, and then if you subtract 315, you'll have negative 42 on the right side. So I just rearranged the 4 equations. And now we're going to put those into a matrix. This will be a 4 by 4 matrix because we have x sub 1, x sub 2, x sub 3, and x sub 4. We're going to reduce this matrix down to row echelon form, and it's very close already as it is. So the first thing we're going to do is add the opposite of row 1 to row 2 and replace row 2 with what we get, because that way row 2 will have a 0 in the first place. So I didn't do that out for you, but I think you can probably do that off to the side. So we want to have a positive 1 for that leading one in the second row. So we're just going to multiply the second row by negative 1 and then change it and make that our new row 2. So that would just be 0, positive 1, 0, negative 1, negative 8. We want to get rid of this 1 right here. So we are going to now multiply row 2 by negative 1. So negative row 2 plus row 3, and we're going to change we're going to take what we get and put that in row 3 to get rid of that 1 there. So if I do that, I'll have 0 plus 0, which is 0. I'll have negative 1 plus 1, which is 0. 0 plus negative 1 is negative 1. And then 1 plus 0 is 1. And 8 plus 34 is going to be 42. So this is reduced row echelon form because remember, as long as there are zeros above the leading ones, it's fine. And this is not a leading one, so that there don't have to be zeros above that. But anyway, what this tells us is that x sub 1 minus x sub 4 is equal to negative 140. The second equation tells us that x sub 2 minus x sub 4 is negative 8. And the third equation, the third row tells us that x sub 3 minus x sub 4 is negative 42. So in part C, it says if the traffic between intersections D and A is 260 vehicles per hour, determine the flow rates x sub 1, x sub 2, and x sub 3. So the flow rates between intersections D and A is your x sub 4 right here. So it's saying if we put that in for x sub 4, what will we have for x sub 1, x sub 2, and x sub 3? So for the first equation, you've got x1 minus 260 equals negative 140, which means that x1 is equal to negative 140 plus 260, which is 120. And then for the second equation, x sub 2 minus 260 is negative 8, which means that x sub 2 is going to be 252 vehicles per hour. And then for the third equation, x sub 3 minus 260 is equal to negative 42, which means that x sub 3 will be negative 42 plus 260 is going to be 218 vehicles per hour. So this would give you an expectation for how traffic would flow depending on, different events and rush hour and stuff like that. All right, so D, if the traffic between intersections D and A is between 250 and 300 vehicles per hour inclusive, determine the flow rates x sub 1, x sub 2, and x sub 3. So now I'm going to look at these three equations. I'm going to get x sub 4 by itself. So x sub 1 plus 140 is equal to x sub 4. So I just moved the x sub 4 to the right and the 140 to the left. And here I've got x sub 2 plus 8 is equal to x sub 4. And then here I've got x sub 3 plus 42 is equal to x sub 4. And I'm putting them like that so that I can work with these ranges the way this is, because it says that x sub 4 is between those two numbers. So that means it's greater than or equal to 250 and less than or equal to 300 because it says inclusive, and that's why I put less than or equal to. So that's where x sub 4 is, which means that 250 is less than or equal to x sub 1 plus 140. And if I look at the second equation, 250 is less than or equal to x sub 2 plus 8, because that's also x sub 4. And then 250, we could say is also less than or equal to x sub 3 plus 42, because that's also x sub 4. So it's asking determine the flow rates for x sub 1, x sub 2, and x sub 3 in these situations. So here I'll subtract 140 on both sides, and that'll be 110 is less than or equal to x sub 1 is less than or equal to 160. And here I'll subtract 8 on both sides, so that'll be 242 is less than or equal to x sub 2, which is less than or equal to 292. And down here I'll subtract 42 on each side, and I'll have 208 is less than or equal to x sub 3, less than or equal to 258. So those would be the ranges for the other traffic flows if x sub 4 was between 250 and 300.